Hello students, welcome to today's class of Ionic equilibrium, question part 2. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So in this session, we will be practicing questions from 10 to 18. Question says that how many liters of water must be added to 1 liter of an aqueous solution of HCl with a pH of 1 to create an aqueous solution with a pH of 2. So your options are A 0.1 liter, B 0.9 liter, C 2.0 liter and D 9.0 liter. Your time to solve this question starts now. Your time is up. So in this question, you are being given that you have to add water to 1 liter of an aqueous solution of HCl whose pH is given as 1. And you have to add the water such that its pH becomes 2. Clear? So what is the answer? You have to add at least 9 liter of water to make the pH 2. So if your pH is 1, that means your hydrogen plus concentration or your proton concentration is 10 to the power minus 1 or 0.1. Now if your pH is equals to 2, then your H plus concentration should be equals to 10 minus 2 or 0.01 molar. Now for dilution of HCl, we are saying that the number of moles will be same. Okay, we are just diluting it, adding water, but not disturbing or changing the number of moles of HCl. Hence, we can say that molarity into volume, that is M1V1 is equals to M2V2. So for the initial condition, we know it very well that we are taking 1 liter of water and your pH is 1, therefore your H plus concentration is 0.1. Okay, so molarity is 0.1 into 1 liter is equals to the H plus concentration for the second condition, which is 0.01 for pH 2, and we don't know the volume. So the volume that we calculate comes out to be 10 liter. Now we know it very well that 1 liter was initially present. Okay, so 10 liter is the final amount. So how many liters of water should you add? You should add 9 liters of water to this solution so that to change the pH from 1 to 2. Next question. The pH of a 0.1 molar solution of the acid HQ is 3. The volume of the ionization constant Ka is, options are A 3 into 10 to the power minus 1, B 1 into 10 to the power minus 3, C 1 into 10 to the power minus 5, and D 1 into 10 to the power minus 7. Your time to solve this question starts now. Your time is up. In this question, you are given the pH of a 0.1 molar solution and it is 3. Now you have to use this pH value to find the value of Ka. So the Ka value comes out to be option C, which is 1 into 10 to the power minus 5. So if your pH is 3, that means your H plus concentration is 10 to the power minus 3 molar. Okay, and this thing is equals to C alpha, right? This is equals to C alpha for a acid like HQ. Now what is alpha here? Alpha is equals to 10 to the power minus 3 by concentration, which is 0.1. If you put this value here, this value comes out to be 0.01. So this is your alpha value. Now, according to Ostwald dilution law, since your alpha is less than 1, hence we can write that Ka will be equals to alpha square C, right? This will be equals to alpha square C. Or else, if you put the value of alpha from here, then it will be 0.01 whole square into 0.1, which is your concentration. So it comes out to be 1 into 10 to the power minus 5. So this is your K value now. Next question, value of dissociation constant K are given as follows. Acids are HCN, whose K value is 6.2 into 10 to the power minus 10. Then it is HF K value is 7.2 into 10 to the power minus 4. Then we have HNO2, whose K value is 4 into 10 to the power minus 4. You have to find the correct order of increasing basic strength of Cn minus, F minus and NO2 minus. So what will be the correct option? Your options are given as F minus is less than Cn minus is less than NO2 minus. Option B, NO2 minus is less than Cn minus is less than F minus. Then option C, F minus is less than NO2 minus and NO2 minus is less than Cn minus. Option D, NO2 minus is less than F minus and F minus is less than Cn minus. So the time to solve this question starts now. Your time is up. We are given 3 acids and along with that you are given the value of K. Okay. Now you have to find that what is the correct order of increasing basic strength of the base. Right. So you have to find the basic strength of this base and you can look at and say that it is of course the conjugate base of these 3 given acids. For HCN it is Cn minus, HF it is F minus and HNO2 it is NO2 minus. So the correct answer comes out to be F minus, NO2 minus and Cn minus, in which F minus is the weakest base, then NO2 minus is stronger than F minus and the Cn minus is the strongest one. We know that the acidic strength of any given acid is directly proportional to the K value. So what is the order of acidic strength? HF is the most acidic with a K value of 10 to the power minus 4 order. And HNO2 is also in the same order, but its initial value, that is 4, is less than this 7.2. So HNO2 is the next strong acid. After that, the weakest acid is HCN, whose K value is 10 to the power minus 10 order. Clear? So this is the order of the acidic strength of the given 3 acids. Now, stronger is the base, weaker is the conjugate base. So conjugate base of a strong acid will be weak and that of a weak acid will be strong. So this order will get reversed for the conjugate bases of the following acids. Cn minus will be the first one. Then we will have this NO2 minus and at last the weakest one is the F minus conjugate base. So this is your order now for the basicity of the given conjugate base or the basic strength of the given conjugate base. Next question, an acid HA ionizes as H plus and A minus, means your HA is breaking into H plus and A minus. So what is the pH? The pH is 5 and the concentration is 1.0 molar. So you have to calculate the dissociation constant. Options are A, 1 into 10 to the power minus 10, B, 5, C, 5 into 10 to the power minus 8 and D, 1 into 10 to the power minus 5. Your time to solve this question starts now. Your time is up for this question. So you are given an acid and its general form is HA and it is dissociating into H plus and A minus. Okay. Now further, its pH is also given and its concentration is also mentioned. You have to use this thing and find that what is the dissociation constant of the given acid, which is HA. Correct answer will be A, which is 1 into 10 to the power minus 10. So your acid dissociation constant would be this much. If we write HA dissociation in terms of concentration, then we can write that initially only HA is present, whose concentration is 1. So we have assumed it as 1. So H plus will be 0 and A minus will be 0 when we have just dissolved it. After T amount of time, suppose this is your what? This is your H plus concentration that is given in. Okay. Because pH is 1, that means your H plus concentration is 10 to the power minus 5. So we can say it very clearly that H plus concentration is 10 to the power minus 5. And this must be coming from this HA. So 10 to the power minus 5 amount is broken from this 1. Hence the similar amount of A minus is being formed after time t at equilibrium. Now your A minus concentration is equals to H plus concentration. Therefore, we can write K as H plus concentration, which is this, A minus concentration, which is this, and your last HA, which is acid concentration. So it is reactant in the denominator and product in the numerator. If you put the values, if you plug the values here, okay, just from here and put it in this equation, that is 10 to the power minus 5 multiplied by 10 to the power minus 5 divided by 1 minus 10 to the power minus 5 from here. Okay, this is the concentration of HA after dissociation. Now you know it very well that this 10 to the power minus 5 is much smaller than this 1. So we can approximate this whole value to 1. Now, if you take it as 1, if you take this thing as 1, then our final K value will be 10 to the power minus 5 into 10 to the power minus 5, which can be written as 1 into 10 to the power minus 10. So this is your acid dissociation constant, or you will simply say dissociation constant. Next question, what will be the degree of ionization of 0.05 molar acetic acid if its pK is 4.74? Options are A, 0.019%, B, 1.9%, C, 3.0%, and D, 4.7%. 4.74%. So the time to solve this question starts now. The time is up for this question. You are given the concentration of this acetic acid, which is 0.05 molar, and you are given the pK value also, which is 4.74. Now you have to calculate the degree of ionization. So the correct answer would be A, which will be 1.9%, which is B, not A, sorry. It will be B, which is 1.9%. If you write the breaking down of this acetic acid, then it can be written as your acetic acid is breaking into acetate ion and hydronium ion, or H plus ion. So initially, suppose we are dissolving 1 mole of this, and you have now 0 mole of this acetate and 0 mole of this proton. After some time, this dissociation will occur, and suppose alpha is the degree of dissociation, then alpha amount will be broken. Okay, 1 minus 1 alpha, you can simply write it as alpha. So 1 minus alpha, so alpha has been broken, so alpha will be formed, alpha moles of this, or alpha concentration of this acetate ion will be formed, and alpha concentration of this hydronium ion will be formed. Now what is pKa? It is minus log K, and pK value is given as 4.74. Now what will be the K value? Just transfer this negative sign here and then take 10 to the power minus 4.74. That will give your K value as 1.82 into 10 to the power minus 5. Further, if you write the K, how will you write it? So on the product side, we have this alpha and alpha. So this is how it is written. So since 1 alpha, or you can say C alpha, is been forming, so you can write it C alpha square here. Okay, C square alpha square here, or C alpha square. Why it is there? Because C is being cancelled out from the denominator. So this is the final equation. So in the down one it will be C minus C alpha, and in the upside it will be C square alpha square. Now if you take C common, you will get C alpha square by 1 minus alpha. Again, since it is a weak acid, your acetic acid is a very weak acid, therefore the dissociation will be very less, and the alpha, which is dissociation, degree of dissociation, it is also very small as compared to 1. So we can write C alpha square by 1 or C alpha square exactly. Clear? Okay. Now if you calculate alpha from here, it will be K by C, or root under K by C, I would say appropriately. So K value is given how much? It is 1.82 into 10 to the power minus 5. Your concentration value is 0.05. If you put both of these values, you will get it as 0.019. Okay. Now multiply this thing by 100. You will get the percentage, which is 9.9%. Clear? Hope you got this question. Next question. HX is a weak acid and Ka value is 10 to the power minus 5. It forms a salt NaX, which is 0.1 molar on reacting with caustic soda. The degree of hydrolysis of NaX is, options are A 0.01 molar, B 0.0001 molar, C 0.1 molar, and D 0.5 molar. Your time to solve this question starts now. The time is up for this question. We are given an acid which is a weak one whose Ka value is 10 to the power minus 5. And now it is forming a salt whose concentration is 0.1. And this we are getting by reacting it with the caustic soda. You have to find the degree of hydrolysis of this NaX. The correct answer is 0.01, which is first option. If you write the hydrolysis of this NaX salt, then it can be written as NaX plus H2O, giving us NaOH plus HX. Clear? So this H2O is breaking down into OH and H. Your HX is a weak acid, we know it, and your NaX is a salt of weak acid and a strong base. So we can write the hydrolysis constant of NaX as KH is equals to Kw by K. Okay. Now if you put the Kw value 1 into 10 to the power minus 14 by A, which is 10 to the power minus 5, that will give your KH value as 1 into 10 to the power minus 9. Further, if you write KH, we can write it as H square by V, or you can write simply CH square. You must have heard this formula. So H is equals to KH by C root under. So from this we got the KH. So we know that 1 into 10 to the power minus 9 is the calculated value of this K, and 0.1. Okay, 0.1 is the concentration. So if you reverse it, you will get the volume. So we have done the same thing. That is multiplied by H square. If you calculate your H square further, it is 1 into 10 to the power minus 9 by 0.1. That will give you 1 into 10 to the power minus 8, or H value is 1 into 10 to the power minus 4. Yes, so this is your answer. 1 into 10 to the power minus 4. So what is the percentage degree of hydrolysis? It is 0.01%. Clear? Okay. Next question. The pKa of a weak acid, HA, and pKb of a weak base, which is BOH, are 3.2 and 3.4. The pH of their salt solution is A 7.2, B 6.9, C 7.0, and D 1.0. Your time to solve this question starts now. The time is up for this question. So the pK of a weak acid, HA, and pKb of a weak base is given as 3.2 and 3.4. You have to find that what is the pH of their salt AB. Okay. So your correct answer will be B, which is 6.9. So this will be your pH. Now for the salt of weak acid and a weak base, pH is equals to half pK minus half pKb. Your pK for HA is 3.2 and pKb for BOH is 3.4, which is given here. Okay, this is for HA and this is for BOH. Now, if we take this value here and put this thing here, then it will get it as 7 plus half 3.2 minus half 3.4. Or we can calculate it further, then it will give us 7 in plus 1.6 plus 1.7, that is 6.9. So this is your what? This is your pH of the resultant salt solution. Next question. Number of OH minus in 1 milliliter solution of pH is equals to 13 is, options are A 1 into 10 to the power minus 13, B 6 into 10 to the power 7, C 6 into 10 to the power 13, and D 6.02 into 10 to the power 90. Your time to solve this question starts now. Your time is up. We are given a solution whose pH is 13, and now we have to find that what is the number of OH minus in 1 milliliter of solution. We know that the correct answer is D, which is 6.02 into 10 to the power 19. Now, moving to the solution. The pH is given as 13 and pOH will be how much then? 14 minus 13, that is 1. What is the concentration of OH minus? So since your pH is 13, then your OH minus concentration is 10 to the power minus 1. What is the moles of OH minus? It is 1.01 by 1000. So that is the moles of OH minus. Now what is its concentration or its ion per milliliter? It is 1 into 10 to the power minus 4, 6.022 into 10 to the power 23 and 6.02 into 10 to the power 19 for calculating. Okay, so after calculating this OH minus concentration comes out to be this thing. Next question, pH of 0.005 molar calcium acetate, that is having a pK of acetic acid as 4.7 is. Your options are A 7.04, B 9.37, C 9.26 and D 8.37. Your time to solve this question starts now. The time is up for this solution question. The pH of a 0.005 molar calcium acetate is to be calculated, whose pH is given, pK is given for acetic acid as 4.7. Correct answer it is D, which is 8.37. Initially, we have this thing which is your calcium acetate. So if it will break down, then it will give us 2 moles of this acetate ion. So that corresponds to 2 into 0.005 or 0.01 molar. So this is the concentration of the acetate ion. Second thing, if we just react this acetate ion with water, then we will get it as acetic acid and the alkaline. What will the pH? pH is equals to half pK by 2 plus half this acetate ion by 2. Concentration of acetate ion by 2. Now pH is equals to 7 plus 2.37 plus the log 0.01 by 2. Further, 7 plus 2.37 minus 1 comes out to be 8.37. So this is your correct answer for the given question. Thank you for attending this session. Hope you enjoyed this class.